Good afternoon, dear students. Yes. So we have completed in the previous class, we have completed D and F block elements chapter. Okay. So today we are going to start with the next chapter, that is electrochemistry. Okay. So this is the chapter from physical chemistry. So first chapter we have seen solution. So this is the second chapter from physical chemistry, that is electrochemistry. Okay. So we are going to discuss about electrochemistry chapter. Okay. So before going for the topic, so can anyone tell me what do you mean by electrochemistry? How do you define electrochemistry? Yes, how do you define electrochemistry? Is it visible now? Audible now? So what do you mean by electrochemistry, students? What do you mean by electrochemistry? Yes, did you study any time about electrochemistry? What is the meaning of this word, electrochemistry? So let us discuss about electrochemistry. So it is a branch of chemistry, okay, which deals with the interconversion of chemical energy into electrical energy. Okay, so it is a branch of chemistry which deals with what? It deals with the interconversion. Okay, interconversion of chemical energy into electrical energy. So you have studied in the first year, okay, about redox reaction. So what are these redox reactions? So redox reactions, so simultaneously, okay, so redox reactions are those reactions where simultaneously, okay, what is that? Reduction as well as oxidation takes place simultaneously, right? So that is the meaning of your redox reaction. Okay, now, so your in electrochemistry, what is happening? Okay, we are applying electric current. Okay, and what is happening? So that your chemical energy, okay, so your chemical energy, it is converted into the electrical energy. So this is the meaning of electrochemistry. So interconversion, okay, it is an interconversion of chemical energy into electrical energy. Okay, so let us start with this topic, electrochemistry. So what are the key terms? Okay, we are going to discuss in this chapter, electrochemistry. So here we are going to discuss about the cells. Okay, we are going to discuss about the types of cells. So here we are going to study about galvanic cells and electrolytic cell. Okay, so before going to the main topic, that is your cells, okay, let us study some of the important concepts. Okay, so some of the basic concepts. So let us study. So here, what all things are involved. Okay, what all things are involved. So we are going to discuss about the key factors like key terms as conductors, okay, Then we are going to study about insulators, okay, and semiconductors, okay, and semiconductors. So let us start. Okay, so first we will start with conductors. Now, what do you mean by conductors? Can anyone tell me what do you mean by conductors? You might have studied these terms in your physics. Okay, you might have studied these terms in physics. What are conductors? What are insulators and semiconductors? So conductors, okay, so these are the substances which allow the passage of electricity. Okay, so here the substances which allow the passage of electricity, okay, to pass through them. So the substances through which the electricity can pass, okay, they are called as conductors. For example, okay, which are the examples? Metals, okay, metal is an example. Then alloys, okay, then graphite, then some of the polymers and electrolytes. So these are what? So electrolytes means what? So the solutions which are made up of ions. Okay. So when these electrolytes are added into water, they will dissociate into their ions. So electrolytes. So what are the conductors? So substances when so substances which allow the passage of electricity. Okay, through them is called as the conductors. What they are called as? They are called as conductors. So this is about conductors. Now, what do you mean by insulators? Insulators, or it is called as non-conductors. Okay, they are called as non-conductors. So it will be opposite, right? So this is opposite to that of conductors. So the substances which do not allow, okay. So here the substances allow the passage of electricity. Okay, passage of electricity. They are called as what? They are called as conductors. And insulators what? Does not allow. Okay, they does not allow passage of electricity. Okay, it does not allow the passage of electricity. They are called as what? Insulators. Okay, so the substances which do not allow the passage of electricity through them, okay, they are called as non-conductors, or they are called as what? Insulators. Can anyone tell me the example for non-conductors? Yes. What are the examples of non-conductors? What are the examples for non-conductor? Your rubber. Okay. Yes, I got wood, rubber, yes, wood. So rubber, wood. Okay, some more. Plastic, right? Then glass, then wax, ceramic. Okay, so these are some of the examples of what? In non-conductors or insulators. Okay, non-conductors or insulators. So substances which allow the passage of electricity. Okay, they are conductors. Which does not allow the passage of electricity, they are called as non-conductors. Next, what do you mean by semiconductors? Semiconductors means what? They will, what do you mean by semiconductors? Can anyone tell me about semiconductors? Yes. What will be the definition for semiconductors? Semi. Okay. So their conductivity is in between. So conductivity is in between conductors. So the semiconductors, their conductivity is in between of conductors and insulators. Okay. So these are the semiconductors. So semiconductors can be pure metals such as silicon, germanium, okay, or compounds like arsenide, gallium, arsenide, or cadmium selenide. Okay, so these are the examples of semiconductors. So these are clear. So these are the important terms, okay, which we are going to use in electrochemistry. Okay, conductors, what are insulators and what are semiconductors. Now next is we will see the types of conductors. Okay, yes, Shivanurni has answered it right. Silicon is a semiconductor. Good. Okay. So next is we'll see the types of conductors. Okay. Types of conductors. So types of conductors. First one is metallic conductor. First one is what? Metallic conductor. Okay. So metallic conductor means what? So these are the metallic substances. So your metallic substances will be present. So these metallic substances, they will allow, okay, they will allow electricity to pass through them. Okay, they will allow electricity to pass. Okay, without undergoing any chemical change. So these are metallic conductors. So metallic substances which allow electricity to pass through them without any chemical change. Without any chemical change. Okay, so this is the meaning of what? Your metallic conductors. Okay. So metallic conductors, they allow electricity to pass through them without any chemical change. For example, so examples are important: copper, iron, aluminium, and graphite. Graphite means what? It is a allotrope of carbon. Okay, it is a allotrope of carbon. So these are the examples of your metallic conductors. These are the examples of metallic conductors. Okay. So in metallic conductors, the conduction, okay, the conduction, it is due to the movement of ions. Okay, it is due to the movement of electrons. Okay, it is due to the movement of electrons. So here it depends on what? It depends upon the nature and structure of metal. So nature and structure of metal. So it depends on nature and structure of metal and the number of valence electron. Valence means outermost electrons per atom. Okay. And the third condition is temperature. So as temperature increases, the conduction will decrease. So these are the three things on which the metallic conductance depends. So what is metallic conductance? Right? So the metallic substances which allow the electricity to pass through them without any chemical change. Okay. So what are the example? Copper, iron, aluminium, graphite. So here the conduction, it is due to what? The movement of electrons. So as the electrons, so metals consist of what? Electrons. Take sodium metal. Okay. Sodium metal, if you write the electronic configuration, it is 1s2, 2s2, 2p6, and 3s1. Okay, 6, 7, 8, 9, 10, 11. So the last electron. Okay, so this is the valence electron. What? 3s1 is the valence electron. So the conduction, it is due to the presence of this valence electron. So the it depends on what? It depends upon the nature and the structure of the metal. It depends on the number of valence electron and it depends on temperature. Okay, it depends on temperature. So these are the important terms. Okay. Okay. Sorry. So there was some Fine. So this is about your metallic conductance. Okay, metallic conductance. So next we are going to discuss about electrolytic conductors. Okay, next we are going to discuss about what? Electrolytic conductors. Now, what do you mean by this electrolytic conductors? Okay, so electrolytic conductors, it is due to the ionic conductance. It is due to what? It is due to ionic conductance. Okay, so these substances, what they do, they allow the passage of electricity. Okay, they allow the passage of electricity through the either molten state or in the aqueous state. So either the metals, okay, either the substances can pass to the electricity, okay, through either molten state or through the aqueous state. So for example, the acid, bases, okay, and salt. So these are the examples of what? Electrolytic conductors. Okay, these are the example of electrolytic conductors. Fine. So, so here the conduction depends on what? The conduction will depend on the movement of ions. Okay. As we have seen that in the, we have seen in the, what? As we have seen, okay. So as we have seen in metallic conductance, okay. So the it depends on what? It depends on the movement of electron. So same way here in electrolytic conduction, it depends on what? The movement of ions. Okay, because ionic conductance means it will be made up of ions. So suppose NaCl. Okay, so when we add this NaCl into water, so what it will happen? So it will dissociate into Na plus ions and Cl minus ion. So the movement, it is due to what? It is due to movement of these ions. Now, on what basis the electrolytic conductance will depend? Okay, on what basic on what base the electrolytic conductance will, so it will depend on what? It will depend on the nature of electrolyte. Then it depends on the charge, size of ions and the extent of solvation. Okay, next is the nature of solvent. It depends on nature of solvent. Then it depends on concentration of the electrolyte. So more the concentration of electrolyte, more ions will be produced and there will be more conduction possible. Then it will depend on temperature. So as you increase the temperature, the electrolytic conductivity will increase. Okay, what will happen to electrolytic conductivity? It will increase. Okay, it will increase with the increase in temperature. So these are the few things about what? Conductance. Okay, so electrolytic conductance. Metallic conductance, it depends on the what? That is the metallic substances. So metallic substances, it will allow the passage of electric current through them, okay, without undergoing any chemical change. In electrolytic conductance, what happened? We take the substances, okay, and we allow the passage of electricity to them through them either in the molten state or in the aqueous state. Okay, so these are the differences between the metallic and the ionic conductivity. Okay. Now, what do you mean by now? Now you might have understood about electrolytes. So electrolytes are nothing but it consists of ions. Now, what do you mean by non-electrolytes? Can anyone tell me what do you mean by non-electrolytes? What do you mean by non-electrolytes? Yes. Yes, non-electrolytes. So the substances which do not conduct electricity. Okay. So electrolytes, they conduct electricity. Why they conduct electricity? Due to the presence of the ions. Okay. Due to the presence of ions, they will conduct electricity. But these non-conductors, okay, non-electrolytes, why they do not conduct electricity? Because the substances, they do not conduct electricity. Okay, either in their molten state or in their aqueous state. So such solutions are called as what? Non-electrolytes. Okay, they are called as what? Non-electrolytes. So electrolytes means what? They will conduct electricity. Okay, in the molten state. But non-electrolyte, they do not conduct electricity in the molten state. For example, glucose. For example, your glucose solution. So take glucose and add it in water. Will it conduct electricity? No, it won't conduct electricity. So that is termed as what? Non-electrolyte. Then ethyl glycol. Ethyl glycol. Ethyl glycol is also example of non-electrolyte. Then urea. Urea is also example of non-electrolyte. Then benzene. Benzene is also example of non-electrolyte. Okay, so these are some of the examples of what? Non-electrolyte. So remember the examples of non-electrolyte, very important. Okay, so these are the non-electrolyte. So now what do you mean by non-electrolytes? The substances which do not conduct electricity either in their molten state or in their aqueous state. Okay, aqueous state means what? When you add it in water. Molten state means when it will be okay, that is when it is liquidifying from solid to liquid. Okay, so that state, it is a molten state. So now if I ask you to give a difference between metallic and electrolytic conductance, so what can be the differences? The first difference for metallic conductivity is what? The metallic conductivity, it is due to what? Movement of what are present, what movement is seen in metallic conductance or metallic conductivity? Yes, what movement is seen in metallic conductivity? So in metallic conductivity, you can see the movement of electrons. Okay, you can see the movement of electrons. But in electrolytic conductance, you can see the movement of ions. Okay. Then on passing electricity, there is no chemical change. When you pass electricity in metallic conductance, you can see no chemical change. But in electrolytic conductance, okay, when you pass electricity, what will happen? The electrolytes will undergo chemical decomposition. It will undergo chemical decomposition. It will get so suppose NaCl. Okay, if I take NaCl and I add in water, what it will happen? It will dissociate into Na plus and Cl minus ion. So it will go undergo dissociation. Then in metallic conductance, okay, it does not involve any transfer of matter. Okay, and in electrolytic conductance, it involves the transfer of matter. That is, ions are transferred. Then in metallic conductivity, what will happen to temperature? The temperature, okay, as you increase the temperature, the metallic conductivity will decrease. But in case of your ionic conductivity, as you increase the temperature, the ionic conductivity will also increase. Okay, so these are some of the differences between the metallic conductivity and electrolytic conductivity. Is it clear? Yes. So these are the important things. Okay. Okay. Next, we are going to study about a strong electrolyte and weak electrolyte. Now, what do you mean by a strong electrolyte and what do you mean by a weak electrolyte? Yes. What do you mean by a strong electrolyte and what do you mean by a weak electrolyte? Anybody knows about strong electrolyte and weak electrolyte? Yes. What do you mean by a strong electrolyte? What do you mean by a weak electrolyte? Yes. So strong electrolyte means what? Yes, Sri Varuni has answered it correct. So electrolyte that will dissociate completely. Okay. So the electrolytes which are completely dissociated into ions, they are called as strong electrolytes. So the ions, the electrolytes which completely gets dissociated, okay, into their ions, they are called as strong electrolyte. For example, strong acids like HCl, H2SO4 and HNO3. So these are the examples of strong electrolytes. Then strong bases like NaOH, okay, KOH and barium hydroxide. So these are the examples of what? Okay, and these are the examples of what? Strong base. Okay, strong base. So they will dissociate. Okay, it will completely get dissociated into its ions. Okay, then strong electrolyte. Then what are the examples of strong electrolyte? Again, in salts, salts like NaCl, KCl, okay, then Na2SO4, then sodium acetate, okay, then ammonium chloride. So these are the example of what? These are the example of your strong electrolyte. Yes. Now, what do you mean by weak electrolyte? So weak electrolyte, they will partially get dissociated. They will not get completely dissociated. They will get partially dissociated. Okay, they will partially get dissociated into ions. Okay. So such electrolytes are called as what? Weak electrolyte. For example, acetic acid, then H2CO3, then HCN, okay, then HgCl2, then AgBr, then ZnCl2, okay, then ammonium chloride hydroxide. So these are the examples of weak electrolytes. So very important, what are strong electrolytes and what are weak electrolytes, okay. Next is about conductivity. Next is about conductivity. Now, what do you mean by conductivity? Okay, so conductivity, so it is the measure of, okay, it is a measure of its ability to conduct electricity. So conductivity, okay, or the specific conductance of an electrolytic solution is nothing but it is the measure, it per meter per, okay, Siemens per meter. So this is the what? This is a unit of specific of conductivity. Okay, it is a unit of conductivity. So where it can be also given as K is equals to G into L by A. Okay, where R represents what? So I'll give you the here. So R is equals to, R is, so R, the electrical resistance. Okay, when we are talking about the electrical resistance here, so the electrical resistance of a material, it will be directly proportional to the length. Okay, that is its cross section area. Cross section area is given as what? Length by area. Okay, so it is L by A, that is 1 by A. So L by, so R is directly proportional to its cross-sectional area, and it is directly proportional to the length, and it is inversely proportional to the cross-sectional area. So it is given as L by A. So if you remove this proportionality sign, then you have to introduce a constant, that is rho, which is given as resistivity. Rho is nothing but resistivity or specific conductivity. Okay. So here, what do you mean by the resistivity? Resistivity of a substance whose length is 1 meter, consider, and having a cross-section area of 1 meter square, okay, is the resistivity. So the SI unit of resistivity is ohm meter. Okay, it is ohm meter. So this is the SI unit of resistivity. So these are some of the important terms. Then what do you mean by molar conductance? Next term is molar conductance. So molar conductance is what? The conduction which is due to the produced due to 1 mole of electrolyte in the solution. So when you have 1 mole of electrolyte, molar means when you have 1 molar conductance. Okay. So the conductance which is produced by 1 mole of the electrolyte in the solution. Okay. So it is called as molar conductivity. So this is molar conductivity. It is given as delta, that is lambda m is equals to K by C. Okay. So K is expressed as cement meter per meter and concentration is in mole per meter cube. Right. So the unit is lambda m, that is of molar conductivity is what? It is cement meter square per mole. So this is the unit of your molar conductivity. So these are some of the example important terms. So molar conductivity, specific conductivity, and molar conductance. So based on that, we will solve some problems at the end. Okay. So let us start about the cells now. Okay, let us start about the cells. So we are going to discuss mainly two types of cell. The first one is the galvanic cell. The second one is the electrolytic cell. Now, what do you mean by electrochemical cell? Okay, as I have told you, what is electrochemistry? Electrochemistry is the study of, okay, it is a branch of chemistry which deals with the conversion of, interconversion of chemical energy into electrical energy. So electrochemical cell, okay, it is a device that converts the, so in electrochemistry, okay, for this interconversion we use a device, and this device is called as what? Electrochemical cell. So electrochemical cell, it converts the chemical energy into electrical energy. So what are the factors? Okay, what are the terms which are involved? So anode. So in the electrochemical cell, so there is one anode and one cathode. Now what is this anode? So anode is the negative terminal. Okay. Anode is a negative terminal. Cathode is a positive terminal. So at negative terminal, oxidation will take place. What do you mean by oxidation now? Oxidation means loss of electrons. Okay. Or addition of oxygen or removal of hydrogen, right? So these are in terms of oxidation. So what happens at anode? It is a negative terminal where oxidation takes place. Okay. Then cathode, it is a positive terminal where reduction takes place. So there will be gain of electrons. There will be gain of electron, addition of hydrogen, removal of oxygen. So this is the meaning of your what? Anode and cathode. So anode is a negative term, okay, terminal, and cathode is a positive terminal. So at anode, what takes place in an electrochemical cell? Oxidation takes place. And at cathode, what takes place? Your reduction takes place. Okay. Now, what do you mean by electrochemical series? Okay. So electrochemical series is the arrangement of various elements and electrodes reaction in the increasing order of their reduction potential. So this we are going to see later. Okay. Let us start with the electrochemical cell. So we know now what is electrochemical cell. Electrochemical cell is a device, okay, which converts the chemical energy into electrical energy. So this is the galvanic cell. Okay, so this is the galvanic cell. So it is a device which generates chemical electrical energy from the chemical reaction occurring in it, or use electrical energy which is supplied to it to facilitate the chemical reactions in it. So two types of chemical cells, electrochemical cells. One is the galvanic cell, another is the electrolytic cell. What is a galvanic cell? So in galvanic cell, the chemical energy, okay, chemical energy of a spontaneous redox reaction is converted into electrical work. So what is done? Whatever the chemical energy, chemical reaction is taking place, okay, so it is converted into electrical energy. So this is process which is undergoing in the galvanic cell. Then in electrolytic cell, what happens? It is a reverse of that. Okay. So electrical energy is used to carry out an spontaneous redox reaction. So here electrolytic solution, electrical energy is used to what for carry out to carry out an non-spontaneous redox reaction. Okay. So galvanic cell. So this is a representation of galvanic cell. You can see there is an anode. Okay, it is a zinc anode which is dipped in the zinc sulfate solution, and this is a silver cathode. Okay, which is dipped in the silver nitrate or silver chloride solution. Okay, so cathode, you can see a positive terminal, and anode, you can see the negative terminal. Okay, and there is this called as salt bridge. Okay, what is the role of this salt bridge? It will help in movement of ions. Okay, so there will be movement of ions which takes place at this salt bridge. Okay, so when you put on the current, so externally these cathode and anode, it is connected by an external switch. Okay, you can see there is a external switch to which the cathode and anode is connected. When you on this switch, okay, when the switch is connected, you can see that the current will flow, okay, in this direction, and to which direction the current is flowing, the electron will flow in the opposite direction. Okay, so this is the working of galvanic cell. Okay, so this is the working of what? Galvanic cell. Very important. What is the working of galvanic cell? Okay, it is very important. So, so the best example of a galvanic cell is what? Daniel cell. Important for 5 marks. Okay, important for 3 marks. So how it is asked? So you have to explain the construction and working of Daniel cell. If it is asked, okay, how it will be asked? It will be asked in this what? You have to explain the construction and working. Okay, of Daniel cell. So this is a Daniel cell. So what you have to write? It consists of 2 electrodes. It consists of 2 electrodes. One is a zinc rod. Zinc rod, it is dipped in zinc sulfate solution. Another is a AG rod. Okay, or generally we take it as copper rod. Okay, you can mention that as copper rod only. Don't take AG. So take it as copper rod. So copper rod, it is dipped in which sulfate solution? So in its respective electrolyte, that is copper sulfate solution. This is dipped in zinc sulfate solution. Zinc is dipped in zinc sulfate solution at anode, and copper is dipped in copper sulfate solution at cathode. Okay, so and these two solutions are taken in a 2 separate beakers. Okay, now the two metal rods, they are connected by the metallic wire. Okay, and the two solutions, how they are joined? They are joined to a inverted U-shaped what? U tube, and this is known as what? Salt bridge. This is called as salt bridge. Okay, and this is the complete circuit or complete construction of the your Daniel cell. Okay, now how the reaction takes place. So let us study how is the working of this. So construction, I have told you the construction. Now let us see the so let us see the reactions which are occurring at the electrodes. Okay, so first one, so as the zinc, okay, so zinc is at negative terminal. So at negative terminal, what takes place? At negative terminal, oxidation takes place, right? So oxidation. So zinc, what will happen? Zinc will give Zn plus 2 electron. Okay, so zinc easily undergoes oxidation to form what? To form Zn plus 2 ions, okay, which will move into the solution. So this is the reaction. Then oxidation is occurring at this electrode. So it is a anode electrode, right? So during oxidation, what will happen? The two electrons are released. Now at cathode, what will occur at cathode? Reduction will occur, right? There will be gain of electron. So copper plus 2 ions, what will happen? They will take up these 2 electrons. They will take up the 2 electrons, which is given in the first reaction, and they will get reduced to copper metal, that is solid form. So copper plus 2 ion, they have a tendency to accept this pair of electron, okay, and they will deposit on the metal, that is copper. So here at cathode, what is taking place? Reduction is taking place. So there is a gain of electrons. Okay, there is a gain of electron. So the electrons, as you are, what is happening? So the electrons will start to move from where? From zinc to copper. Okay, and it will generate electricity. So the direction of the current flow is opposite. So we have know that. So direction of current flow is opposite to that of the electron flow. So what is the net reaction now? What is the net reaction? So the net reaction is Zn plus copper plus 2 aqueous, giving you Zn plus 2 plus copper solid. Okay, so this is the overall cell reaction. Understood? Yes. So what is this salt bridge? Okay, what is this salt bridge? So a small explanation about salt bridge also very important. Okay, it is a U tube. Okay, it is a U shaped tube. Okay, it is a U shaped tube. Okay, which is containing a semi-solid. It consists of semi-solid, okay, or semi-solid of an electrolyte such as KCl or potassium nitrate or ammonium nitrate, okay, in gelatin or agar-agar, in gelatin or agar-agar. So this is about the U-shaped salt bridge. So in the salt bridge, what is present? Semi-solid electrolyte of KCl, okay, or potassium nitrate, or what? Or this what? Okay, KCl, potassium nitrate, or ammonium nitrate. Okay, in the gelatin or zinc sulfate, or that is gelatin or agar-agar solution. Okay, so this electrolyte, whatever the electrolyte is there, it contains cations and anions of equal mobility. So the cation and anion which are present in this U-tube shape, they are having same mobility. Mobility means what? They have the same tendency. The movement or the speed of the ions is same. The both the ions, that is cat ion and anion, the speed, the mobility, the movement of these ions is same. Okay, they can move at the same speed. The salt bridge, okay, what it will do? It will prevent the liquid junction potential and the intermixing of electrolytes. So what is the role of this salt bridge? It helps in preventing the liquid junction potential and the intermixing of electrolyte. Okay, so this is about the Daniell cell. Is it clear? Okay, so very important, Daniell cell. So Daniell cell is very important. So what is Daniell cell? Okay, construction and working of Daniell cell. So the question can be explain the working and construction and working of Daniell cell. Okay. So the Daniell cell, how much energy we are supplying? Okay, how much electric current we are supplying? The current supplied is 1.1. The current supplied is how much? 1.1 volts. How much? 1.1 volts. Now suppose a condition. Okay, if an external opposite potential, that is, if you put an external potential more that is less than 1.1, okay, then what will happen? The electron flow from zinc to copper. Okay, the electrons will flow from zinc to copper, and the current will flow from copper to zinc. When it will flow? When the external potential, okay, which is applied is less than 1.1. Okay, so what will happen? The zinc will dissolve at anode. It will dissolve. Zinc dissolves at anode, and deposits copper deposits at cathode. Copper deposits at cathode. So it will act as a electrochemical cell. Okay. Now, if the external potential is equal to 1.1, what will happen if the external potential is applied? The applied is 1.1. Then there won't be any flow of electron. No flow of electrons or current. Okay, or current. So when the external potential, okay, if it is equal to 1.1, then no flow of electrons or current. So there won't be any chemical reaction. So no chemical reaction. No chemical reaction. Okay. Then if external this current, okay, it is greater than 1.1 volt. If it is greater than 1.1 volt, then what will happen? Can you tell me from where the electrons will start to flow? From where the electrons will start to flow? The electrons will start to flow from copper to zinc, and the current will start to flow from zinc to copper. Okay, zinc to copper, and they will this type here the cell will it will what it will behave as a electrolytic cell. Okay, it will behave as a electrolytic cell. So this is the difference. Okay, so when you have a Daniell cell, okay, Daniell cell, when the external potential applied to the cell is less than 1.1, then it will act as a electrochemical cell. If the external current is equal to 1.1, then it will act as, then there won't be any chemical reaction. If the external potential applied is greater than 1.1, then what will happen? The electrons will flow from copper to zinc, and current will flow from zinc to copper. Okay, and the zinc will start to deposit at the zinc electrode, and copper will dissolve at the copper electrode. So what will it will behave as? It will behave as a electrolytic cell. Is it clear up to here? Yes. So very important, working and construction is very important about Daniell cell. So remember, please try to remember the things. Okay. So very important. Yes. Okay. So others, what about others? Okay. So what you do? I think a bit confusion will be there with you all. So what you do? So just read again. So read again today. Okay. You read it. So after reading, still if you find any difficulty, you can come to me tomorrow. Okay, you can ask the doubts tomorrow. So read up to this construction and working of Daniell cell, very important. Okay, so how the cell representation and all is there, so that we will do it in the next class. Okay, so I hope you have understood. Okay, please go through the, if you have textbooks, okay, please read this chapter electrochemistry, so that some of your doubts will be clear. Okay, still, if you have any doubts, you can come to me tomorrow. Fine. So, thank you. So, I'll end the session here. Okay, we'll meet in the next class.